All right, let's take a look at 6.4, question number 4. So the overhead reach distances of adult females are normally distributed with a mean of 205.5 centimeters and a standard deviation of 8.9 centimeters. Find the probability that an individual distance is greater than 215.50 centimeters. Okay, so first thing I did is I just wrote this information down. I drew a little picture. All right, so I wrote the information down. I've got my mean of 205.5. I've got my standard deviation of 8.9. I created a little normal curve right here with 205.5 in the middle. And we're interested in the probability that an individual distance is greater than 215.5. So that's going to be obviously somewhere above the mean. So we're going to go to StatCrunch. And then we're going to enter, we're going to go to Stat Calculators, Normal. And then we're going to enter our mean of 205.5. And then we will enter our standard deviation of 8.9. And we're looking for the probability that x is greater than 215.5. So we're going to change that to greater than. And then we're going to put 215.5 in here. And then we're going to hit compute. So we get a value of 0.1306 if we round to 4 decimal places. So let's put 0.1306 in here. All right. Now, the second part is interesting. This is where we start talking about the central limit theorem. So find the probability that the mean for 20 randomly selected distances is greater than 203.30. So this makes for a little bit different of a problem. So we now have a value of n is equal to 20. And we're looking for the probability that the mean, the x bar, is greater than 203.30. So the way that we calculate this is we want to, here, I'll show you, I'll write it down, all right? All right, so in the previous example, in part A, we had the mean is equal to 205.5, and we had the standard deviation is 8.9. But now that we're talking about finding the probability that the mean is greater than 203.30 with n equal to 20, we have to recalculate our standard deviation. In fact, so our mean of x bar, this will remain the same. This will be 205.5. But the standard deviation for x bar will now be 8.9 divided by the square root of n, or in this case, the square root of 20. So I'm going to take this and plug it into my calculator. So I've got 8.9 divided by, and then I'm going to take the square root of 20, then hit enter. And that gives me about approximately 1.99. So this is approximately 1.99. We have to use this as our new standard deviation now. That's our new standard deviation. So when we enter the numbers into StatCrunch, we're going to enter, let's see if I still have StatCrunch available here. Okay, so we have a mean of 205.5, and we have a standard deviation is no longer 8.9. It's now 1.99. And then we're looking for the probability that x bar is greater than 203.30. So we have to change this to 203.3. Then we hit compute. Now the probability that the mean of 20 reach distances being greater than 203.3 is 0.8655. So let's enter that here, 0.8655. And now the question is, can the normal distribution be, why can the normal distribution be used even though the sample size does not exceed 30? Because they tell us in the problem that the overhead reach distances are normally distributed. So it's not A. Normal distribution can be used because the original population is normally distributed. And that ends this lesson.